Okay, so today in 4-4, we're talking about linear inequalities in two variables. So we're going to be graphing just like what we've done in the past on a graph with linear functions, but now we're going to have to be shading our graph because it's an inequality. It's not just equal to the line, it's going to be greater than or less than, greater than or equal to or less than or equal to that graph. So to start off, let's fill in this chart. When we are graphing a solid line, so it's going to look just like what we've graphed in the past, that is when you have a less than or equal to or a greater than or equal to. Then we're also now going to be graphing a dashed line, or a dotted line, I may say sometimes. This is when we're dealing with just less than or greater than. There's no equal to. Okay, so we also have a little reminder that when we're dealing with inequalities and we're solving a function, we multiply or divide by a negative number, we must flip the inequality. So that's a little reminder back from that unit 1. Whenever we solve and we multiply or divide by a negative, we have to flip that inequality. So let's look at this first example. We need to graph y is less than or equal to x minus 1. So first off, I can see that my b is -1. So I'm going to begin at -1. And then my slope is a 1x or a 1/1. So I'm going to go from that point that I just plotted, and I'm going to go up 1 and right 1 as far as I possibly can go. Once I run out of space, I could go the opposite direction and go down 1, left 1, as far as I possibly can go. Okay, then I need to look at that inequality. It tells me that we are less than or equal to. Since it is equal to, that tells me that I'm going to be graphing a solid line. So draw your solid line across those dots that you just plotted. Then we have to shade our graph. So let's write ourselves a little note to the left of this graph. If we have anything that says y is less than or y is less than or equal to, we are going to shade below the line. If we have anything that's y is greater than or y is greater than or equal to, we are going to shade above. You can also test this with a point if you need to, but let's use this rule. So we have our inequality saying we are less than or equal to. So since we are less than, that tells me that I'm going to shade below my graph. So everything below my line, I am going to shade. This means that all the points on my line, as well as all of the points in that shaded area, would be a true statement for y is less than or equal to x minus 1. So if I were to test a point in that shaded area, I can see that the point 2, -2 is in that shaded area. So let's test that, and it should be true for my inequality. Y is less than or equal to x minus 2. So we found that the y was -2, is less than or equal to, and our x was 2 minus 1. So 2 minus 1 is 1, and I know that -2 is less than or equal to 1. So I shaded my graph in the right area. Okay, let's do another example just like this. This one, we have 2x minus 3y is less than 12. So right off the bat, I am not able to graph this because it does not have a y equals, or in this case, a y is less than. So we need to solve for y. So I'm going to start off by doing that by subtracting 2x. So that's going to give me negative 3y is less than 12 minus 2x because I cannot put those together. And then I need to divide both sides by negative 3. Everything is going to be divided by negative 3. And this reminds me back to what we said in the beginning, that we are dividing our inequality by a negative number. So that means that I am going to have to flip this inequality. So now it's going to become greater than, and I do 12 divided by negative 3 is going to give me negative 4. And negative 2 divided by negative 3 is going to give me a positive 2 over 3x. So now that I have my inequality solved for y, I can go and graph. So my b is negative 4, so I'm going to begin at negative 4. And then my slope is 2 over 3, so I'm going to go up 2 and right 3 as far as I possibly can go. Up 2 and right 3. Then I run out of room and I can go the opposite direction, going down 2, left 3, down 2, left 3, as far as I can go. Then I need to pay attention to my inequality. It is less than, it's not equal to, so that means that I am going to graph a dashed or dotted line. And then I need to figure out where I'm shading. Since now that we are greater than, that tells me that I'm going to be shading above my line. So everything that is above my line, I am going to shade. Okay, let's try another example. Example 3. We need to graph y is greater than or equal to negative 5. Now, this does not have an x in it. So off the bat, I need to recall, how do I graph a y equals just a number? This is back to our Hoy and Bucks that we talked about in Unit 1. Since this is a y, we're talking about a Hoy. So we're going to have a horizontal line with a slope of 0 since our equation says y equals just a number. Okay, so I'm going to go and graph this. I'm going to go to negative 5 on my y-axis. And since I have a Hoy, I'm going to graph a horizontal line. Now, before I do that, I need to pay attention to my inequality. My inequality said greater than or equal to. So since I was equal to, that tells me I have a solid line. So let's graph that solid line. And again, since I was greater than or equal to, I'm going to shade above my line. So everything above my line is where I'm shading because I was greater than or equal to. Okay, let's try another example. Example 4. Now we need to graph x is less than 6. Now, this is a Hoy and Buck situation. Again, we don't have a y in this equation. So since it is x is less than or less than 6, I have a Bucks equation. So I'm going to be graphing a vertical line. So I'm going to go on my x-axis to positive 6, and I'm going to be graphing a vertical line. But I need to pay attention to my inequality. We had an inequality that was less than. It was not equal to, so I'm going to graph a dashed line. A dashed vertical line. Now, there is no above and a below on this one for my shading. So we have to think about kind of like a number line. It said x was less than 6. So I need to shade all of the numbers that were less than 6 on the x-axis, kind of. So all the numbers that are less than 6 are to the left of my line. So I'm going to shade everything to the left of that 6 because that is where it is less than 6. Okay, let's try another. Okay, looking at example 5, it says that the Science Club sells t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet or exceed their goal? So this picture over here tells us that their goal is $500. So they want their things that they are selling to be greater than or equal to that $500. That's the goal. And they're going to do that by selling t-shirts. So we'll say that that's our X. And they're selling keychains. We'll say that's our Y, because they're selling 2 different things. So an equation to represent this would be 10x, because they're selling their t-shirts for $10, and 2y because they're selling their keychains for $2. That profit needs to be greater than or equal to that $500. That's the goal. So if I want to graph this, I need to first solve this equation for y. So I'm going to subtract 10x, giving me 2y is greater than or equal to 500 minus 10x. Then I'm going to divide everything by 2, giving me y is greater than or equal to 250 minus 5x. So if I go to graph this, I need to first label my axes. My x-axis is my t-shirts. And my y-axis is my keychains. Then if I need to label or number my graph, I'm going to number, let's count by 2's down on my x-axis. So 2, 4, 6, 8, 10. I'm only going to label every couple because it's super close together on mine. And then it will be 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So I have 4 slashes in between each one. 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, and then 52. So I counted by 2's, but I really only labeled the 10's. Okay, so there's my t-shirts on my x-axis. Let's number our y-axis. So I'm going to count by 10's on my y-axis, but I'm only going to label every couple ones. So 10, 20, 30, 40, let's label the 50. 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, 240, 250, 260, 270, 280, 290, 300. Let's stop there because we know on the side with our equation that we're going to have to begin on 250. So let's put a point right there on our graph. And then our slope was -5. So -5 over 1. So that makes it a little tricky. We counted by 10's. So if I change this slope to be counting by 10's, I could multiply my slope by 2 on top and bottom, which would give me -10 over 2. Well, that really helps us since we counted our x-axis by 2's. So if I go down 10, down 10, that would be down 1 dash, and right 2, that would be over a dash since we counted by 2s. So I'm going to do that all the way down my graph. Down 10, right 2, down 10, right 2, as far as I can go. Once you get this, all your dots plotted, we're going to have to make a line. Now, my equation said greater than or equal to. So since it was equal to, I'm going to make a solid line. And then since it was greater than, I'm going to shade everything above my line. So what does this mean? Why are we graphing this? What does this mean in the situation of selling keychains and t-shirts? Basically, any point on this entire graph is a combination that would either meet or exceed our goal. So the point, if I look, 30 t-shirts and 100 keychains. So this point right here would meet our goal. If we sold exactly 30 t-shirts and 100 keychains, we would get exactly $500 since it was on the line. Anything that is above our line in this shaded region tells us what would exceed our goal. So any point up here, if we had 30 t-shirts and 200 keychains, we would make more than $500. Okay, let's look at another example. Example 4. Are the following points a solution to the graph below? Okay, so let's look at each of these specific points together. I'm not sure that this is the shading is shaded on your note packet. So let's all make sure we shade everything that is above the line. So make sure that that's shaded on your notes packet first. Okay, once you have that shaded, we're going to look at each one of these points and determine if they are solutions. Now remember, if something is a solution to an inequality, it has to be in the shaded region. Okay, so let's look at the point 0, 0. Is 0, 0 a solution to the graph? The point 0, 0 is right here, which is in the shaded part of our graph. So we would say, yes, this is a solution to this inequality. 4, negative 4. So 4, negative 4 is right here, which is not in our shaded area. So we would say, no, this is not a solution. Okay, last one is 1, negative 2. 1, negative 2 is on the line. And since that line is a solid line, we would say yes. Now, if that point was on the line and our line was dashed or dotted, we would say no, it is not a solution because the dashed or dotted is not equal to. Okay, looking at example 5. Are the following points a solution to y is less than or equal to negative 1/2 x plus 1. So each one of these points we need to check, and we're going to do that by plugging in these numbers for x and for y to see if they make a true statement for our inequality. So I'm going to do that. Y is less than or equal to negative 1/2 x plus 1. And they told us that the y was 1 and the x was negative 2. Now, if I calculate in my calculator, negative 1/2 times a negative 2 is going to give me a positive 1. And then positive 1 plus 1 is positive 2. And I asked myself, is 1 less than or equal to 2? And I would say yes. This is a true statement, so the answer is yes. Negative 2, comma 1 is a solution. Okay, let's ask ourselves the same thing for the next one. We want to check the point 2, 4. So we're going to plug those numbers in for x and for y. So in our equation, the y was 4, and the x is 2 this time. So if I calculate in my calculator, negative 1/2 times 2 is going to be a negative 1. And negative 1 plus 1 is 0. Now, 4 is not less than or equal to 0, so I would say false. Two comma 4 is not a solution.